We have a triangle ABC. It's given here that the ratio a squared minus b squared over a squared plus b squared, so that's equals to sine of a minus b over sine of a plus b. We need to show that this triangle ABC, it could be either a right angle triangle or it could be an isosceles triangle. So let's begin. So first, what we'll do, we will state the laws of sine. Before that, let us consider a acute angle triangle. So for this particular case, this we have to prove that it is also a right angle triangle, but for the purpose of generality, we are using an acute angle triangle. It holds true for an obtuse angle triangle or even a right angle triangle. So let's name this triangle ABC. Then the side opposite to angle A, which is represented by BC, we're going to use you are going to denote it by the letter A in lowercase. Then for angle B, the side opposite to it, which is AC, we're going to represent it by the letter B in lowercase. And for angle C, the side opposite to it is AB. We are going to represent it by the lowercase letter C. So the laws of sine, the law of sines, it tells us that the ratio of side A to that of sine of the angle opposite to that side, which is angle A, this ratio is equals to the ratio of side B to that of sine of the angle opposite to it, which is B. This is also equals to the ratio of side C to that of sine of the angle opposite to it, so that will be sine C. So this is the law of sine. Now what we'll do, we will suppose that this ratio, let it be equals to a common constant lambda, such that we can represent A as lambda times sine A. Then B will be represented by lambda times sine B, and C will be represented by lambda times sine C. Now what we'll do, let's start with our given condition. So here we are given the ratio a squared minus b squared divided by a squared plus b squared. So that's equals to sine a minus b divided by sine a plus b. Fine. So we'll substitute the value of A with lambda times sine A and B with lambda times sine B. That which was going to give us sine squared A minus sine squared B divided by sine squared A plus sine squared B. And on the right hand side, we have the ratio sine of A minus B divided by sine of A plus B. Now, our task will be to first find out the value of sine squared A minus sine squared B. So let's do that. So we know that sine squared A minus sine squared B. So this can be expanded to get sine of A plus sine of B multiplied to sine of A minus sine of B. Now what's the sum sine A plus sine B? So that's 2 times sine of A plus B over 2 times cosine of A minus B over 2. Then the difference, sine A minus sine B, that's given by 2 times cosine of A plus B over 2 multiplied to sine A minus B over 2. Now we can rearrange the factors to get 2 times sine A plus B over 2 multiplied to cosine of A plus B over 2. Then we have 2 times sine A minus B over 2 times cosine of A minus B over 2. Now 2 times sine A plus B over 2 times cosine of A plus B over 2, that's sine of 2 times A plus B over 2. Similarly, this will become sine 2 times A minus B over 2. So 2 and 2 gets factored out. This is going to leave us with sine A plus B multiplied to sine A minus B. Now that means sine squared A minus sine squared B. This can be replaced with sine of A plus B times sine of A minus B. So let's do that. So we're going to get on the left hand side, the numerator portion will be sine A plus B multiplied to sine A minus B divided by the denominator, which we obtained as sine squared A plus sine squared B. So this will be equals to sine A minus B divided by sine a plus b. Now to simplify, we're going to work from here onwards. So we know that in the triangle ABC, the sum of the interior angles a plus b plus c, so that's equals to pi radians. So if we want a plus b, so that will be equivalent to pi minus c. Taking the sign on both sides, we're going to get sine of a plus b, which will be equals to sine of pi minus c. Now what's the value of sine pi minus c? So that's simply sine c, and it's going to be positive since the angle pi minus c lies in the second quadrant. Now that means sine c can be also said to be equivalent to sine a plus b. So we'll replace the sine a plus b and the sine a plus b with sine c, which will give us sine c multiplied to sine a minus b whole divided by sine squared a plus sine squared b equals to sine a minus b divided by sine c. Fine. Now what we'll do, we'll transpose the fraction from the right hand side to the left hand side. So we'll get sine a minus b, so that can be taken as the common factor. So this will get multiplied to sine c divided by sine squared a plus sine squared b minus, so we've already taken sine a minus b common, we have 1 divided by sine c. So this equates to 0. We can have sine a minus b, so either this could be equals to 0, or we could have sine c. So if we combine them, we're going to get sine squared c minus sine squared a minus sine squared b whole divided by sine c multiplied to sine squared a plus sine squared b. So this will be equals to 0. Now let's solve these two equations. Now that we have sine a minus b equals to 0, this would clearly mean that a minus b must be equals to 0. Now if a minus b is equals to 0, then we have angle a equals to angle b. Now clearly think about this. We have a triangle, we have angle a, angle b, angle c. So just now we have found out that angle A is equals to angle B. So that means the side opposite to angle A, which is A, and side opposite to angle B, which is B, so they must be equal. So A equals to B as well. So this means that the triangle is isosceles. So we prove one part. Now let's come to the next part. So from this equation, we're going to get the numerator part, sine squared C minus sine squared A minus sine squared B. So that becomes equals to 0. So we multiply the denominator with 0. Arranging the terms, we get sine squared A plus sine squared B equals to sine squared C. Now we've already defined by using the law of sine that A is equals to lambda times sine A. So that means sine A will be equals to lambda over A. So similarly, we can define sine B and sine C. So let's plug this value here. So sine squared A will become a squared over lambda squared. Then sine squared b will give us b squared over lambda squared, which will be equals to sine squared c, so that will be c squared over lambda squared. If we factor out 1 over lambda squared from both sides, we're going to get the result a squared plus b squared equals to c squared. And this is the condition that tells us that the two we have a right angled triangle, which is right angled at C. So this is a right angled triangle. So we have proved it with the given condition. So the triangle could be either an isosceles triangle or it could be a right angled triangle.